Welcome to the students of management in this program. I am Dr. P.C. Basak. Professor of Management in School of Management Studies of IGNOU. I am delivering a lecture on the topics of management of materials and machines. So my first lecture will be on the basis of some general viewpoint on management of machines and materials. This subject is common to certain branch of the engineering as well as to the all MBA students. It is a compulsory paper for MBA students also. So this management, there we have the different names. Usually we call it as an production and operations management. We can call it also as manufacturing management. We can call it also management of material, management of production systems. At the same time, sometimes we can call it as industrial engineering. So let us see some of the definitions that incorporates in this name of the subjects. So first is that the name is the management. Although we all are the management students, but still I will quote some of the definition given by certain important personalities of management educations of the world. One is that Peter Drucker. So the definition given by the Peter Drucker about the management is that management is a multi-purpose organ that manages a business and manages managers and manages workers and work. If one of these were omitted, we would not have management anymore, and also we would not have business enterprise or an industrial society. Management as a subject has grown up from the industry, and subsequently from the 70s or 80s decades onwards, it started applying many of the known techniques in non-manufacturing sectors also. So this is the definition given by the Peter Drucker is relevant mostly in any kinds of business enterprise, whether it is a manufacturing or it is a non-manufacturing. Also he has given one more extension of this definition is that management is doing things right, leadership is doing the right things, management is the efficiency in climbing the ladder of success. Leadership determines whether the ladder is leaning against the right wall, because the success of the management and success of the business enterprise or an industrial organization, it depends upon the leadership as well as team building and how the leaders, they organize the peoples, those who are hierarchically working at their lower level to lead the whole organization towards the goal of the organizations. So this is the general sum of the definition of management and task of the management. Now let us come to the concrete area, that what we call, as we told, that this subject has grown up from the industrial engineering, and what we call scientific school of management thought. The father of the scientific school of management thought is F.W. Taylor. He gave the name of the subject as the industrial engineering, and many of the techniques that is used or taught in production and operations management or manufacturing management or industrial engineering are same. And that's why I am tempted to quote the definition of industrial engineering also. And this definition is given by American Institution of Industrial Engineers, that is in brief we call AIIE. The definition is like this: industrial engineering is concerned with the design, improvement and installation of integrated system of men, materials and equipments. It draws upon specialized knowledge and skill in mathematical, physical and social sciences together with the principles and methods of engineering, analysis and design to specify, predict and evaluate the results to be obtained from such systems. So here this definition incorporate the systems viewpoint of the whole production systems by incorporating man, materials, equipment and drawing knowledge from various areas of existing knowledge including engineering, physical and social sciences. So as a whole we can say, we also know the management is not as such an one independent discipline, but it has borrowed the knowledge from various disciplines and made a good synthesis of various knowledges in the management. So industrial engineering also tries to look at the problem from that viewpoint, and many of the techniques that has evolved in the beginning of the 20th century by F.W. Taylor in the name of Principles of Scientific Management School of Thought, that is nothing but equal to the industrial engineering. So since I am quoting this definition of industrial engineering because this subject is also known as industrial engineering, so that let there not be any confusion with what is industrial engineering and what is manufacturing management and what is production and operations management. Now let us see another definition, since we are very much interested, always call the systems, manufacturing systems, production systems. So what is the manufacturing systems? A manufacturing systems can be defined as a system in which raw materials are converted into finished products through different stages of processing, gaining higher added value at each stage. It is a very simple definition, and this shows that it is a raw material has to be converted into finished product as desired by the customer, decided by the manufacturing organization. It may be a non-manufacturing organization also, but it goes through the different processing sequences and also adding value at each stage of operations. If we don't add value in each stage of operation, there is no meaning of conversion. So there are various types of manufacturing systems. It can be machine building industry, it can be automobile industry, it can be chemical industry, it can be material processing industries like steel plant, or non-ferrous industries like aluminium, zinc, copper. It can also be textile industries, leather industries, which incorporates shoes manufacturing, garments manufacturing, many other luxury goods manufacturing. So, but technology applied for the raw material conversion is different in different industries. So characteristics of the industries varies with the variation of the industries. There is nothing common in the conversion process, but the management of all these conversion systems or manufacturing system has to be certain common knowledge. So this diagram of three flows diagram, that settles the basis for analyzing any kinds of manufacturing systems. The first flow, so it consists of the three flows. First flow is the raw flow of materials, that is the horizontal flow. Raw materials, it works as an input for the transformation process, and obviously transformation process is different for different kinds of industries, and ultimately it is converted into the finished product. And every stages of the conversion we add certain amount of value to that, and that we call the flow of cost or value. That is another flow in these systems. We add value, and definitely we are incurring certain amount of cost while adding the value. So the cost must be less than the value added. If your cost incurred for addition of the value is more than the value added, then what is the point of conversion and what is the need of such conversion? It is nothing but a sheer wastage. So we are very much concerned about the how much value we have added and what cost we have incurred for that kind of activities. And we need another kind of flow. At every stages of conversion, if it is a multiple stages, and most of the manufacturing systems is a multi-stage manufacturing systems. Each stage needs to be controlled and monitored. At each stage we decide certain amount of value to be added, but it needs to be monitored. For monitoring, controlling, we need certain another flow, that is the vertical flow in this diagram, that is flow of information. This flow of information is made for planning and controlling purpose. This flow of information in industrial organization, there is a separate set of department that organization, that is called, we call usually production planning and control department. They do such activities in that. It is a huge task, and computer today that makes it easier for planning and controlling activities. When computer was not there, that used to be a glorified clerical activities. But it has the immense importance in any kinds of industry, or even it is a non-manufacturing industries. Suppose a large hotel like Oberoi Grand or La Meridian, this kind of hotel. They have large number of rooms, 100 number of rooms. Each room of different varieties. Each room needs certain resources. Customer needs certain comfort, and customer is paying for that. So the task of the organization to cater, to meet the customer's demand, for which it has been designated and for which they are ready to pay certain amount of value for that. So in exchange of the money paid, they also expect certain amount of return. So how to manage this such kind of complicated affairs? Definitely you require the production planning and control department. Maybe the name of the department is not production planning and control, because you are not producing certain goods in this kind of industry. You are delivering certain services. So name may be different, but activity will remain same. Same as corporate hospitals like coming up, Apollo sets a group of hospitals. It is the first group of hospitals in our country. It came in the non-manufacturing sectors for providing the better healthcare services to a certain kinds of people. We can say it is also these customers, and how to cater different facilities to the different customers, and for which they are definitely charging much higher than the government hospitals. So when customer or a patient is ready to pay such amount of money for the healthcare delivery, they expect much better services than how to organize these things. For them also you require the flow of information, but how to organize it. So this is the set of definitions that we are dealing with. Also manufacturing system is not that just conversion. For conversion you require lots of other facilities. What are those facilities, and how, again, some extension of the definition that we have seen in the previous slides. This can be called as a manufacturing system. The manufacturing system is an unified assemblage which includes workers, production facilities. Production facilities mean machines, including its tools, jigs and fixtures, material handling equipment and other supplementary devices. This is supported by production information, namely production methods and technology, that is technical know-how. So just for conversion process, all these things are necessary. That is the production machines, including its tools, jigs and fixtures, workers, management, and also technical know-how. Now this subject in management is also known as the operations management, and there we define in this way. Operations management is the process whereby resources flowing within a defined systems are combined and transformed in a controlled manner to add value in accordance with the policies communicated by the management. Because ultimately the product that you are going to deliver to the customer, that is a policy, it is top level policy decision decided by the management in any industrial enterprise. So it also includes the value added activities, and these value added activities, so all the resources has to be combined in that. We define the operations management in that way. Now schematically we can see that the transformation activities, we have these inputs, man, machine, materials, energy and information. That is an input transformation activities. We have this output side, product, goods and services, then some non-manufacturing activities, that is the output, and we have a feedback loop in the bottom that we call this control system. Usually if the desired product is not, desired output is not obtained, in that case defects may be, either it may be in the transformation activity or maybe the quality and quantity of the inputs. That one has to find out in the day. But in general we have a feedback loop so that planning and control activities can be done properly. And all these things, again, you are operating in an environment. So this environment is a multifold activities. That means it includes your political, economical, social and technological environment. So this also you can say the legal environment, because nowadays environmental rules government is trying to enforce upon the manufacturing. So this will also change certain amount of input qualities, maybe transformation process. That means this output from the transformation activities needs to be reoriented or reprocessed to conform to the environmental legislation of that state or country. So we have the also the environmental feedback. And also, as the technology changes, social and political environment changes, customer aspiration for the product in terms of the design, in terms of the cost, quality, that also gets changed. So what do you want to mean by this process? That your transformation activity is not the simply static for a longer period. It may be static for certain period, but it is a dynamic situation. Every few years one needs to audit its activities so that whether there is to find out whether there is a need for changing the product, changing the product design, product quality and quantum of the operations in that. So that's why we need that environmental feedback. Now from these definitions, what we have studied till now, we have understood that there are few terms from this definition. We will discuss now what are the issues that related with these terms. First term is that resources. There are three main resources, that is human resource, material and capital. Now human resources, what we used to think at the beginning of the 20th century and what we think today, there is lots of differences. So what are those issues that needs, I would like to discuss some amount of that. Human resource issues, previously how we have done it, we have broken down a job into number of smaller activities. And these smaller activities we try to give to the labor, and labor will be trained only in these small activities, and that labor for a longer period of time used this kind of job. So that's why we used to call it is a mindless stereotype task, mostly in the assembly line or in the, that means the assemble of the finished product, like all consumer durables starting from the automobiles, whether it is a four-wheeler or two-wheelers, then refrigerator industries, TV industries, washing machine, all sales that will come in that assembly lines. And these assembly lines task, every worker or a group of our workers are doing a minuscule amount of task, and they develop their skill in that particular task. Not much thinking abilities are required, and that we call mindless stereotype task. But today we are redesigning the task of the workers, and that we are calling planning and controlling activities. So what we used to call this mindless stereotype task, today we need, that is moving towards the planning and controlling activities. There is a reason for that. Previously we have, suppose we take just machine tools, we have the center lathe, capstan and turret lathe. Today we don't use the capstan and turret lathe. We use NC machines, various kinds of machines, CNC machines. Now the skill required for operating one capstan and turret lathe is definitely different than the skill required for operating one CNC lathe. Now that skill, due to the skill requirement different, we need to incorporate certain or redesign the job in such a way so that planning and controlling activities are incorporated in that task. So if we want to incorporate the planning and controlling activities, we need to redesign our job design, work design and workplace design in a different way. Also we are increasingly concerned about the workers' satisfaction with increased productivity. Productivity is a one term that we always from the beginning of the 20th century, how to measure the worker productivities, particularly labor productivity, capital productivities. Economists are also concerned about it. At the same time, industrial engineer and production and operations managers are also concerned about the productivity. But at that time, we never used to thought about the workers' satisfaction. Today, from 1980s onwards, as the Japanese manufacturing industries, they started competing with European and American industries. We are gradually becoming more concerned about this workers' satisfaction. It doesn't mean that we are forgetting the productivity. We are keeping in mind the productivity and improving the productivity, but with the workers' satisfaction. So we have to reorient our human resource systems. In one way, we are meeting the customer's demand. At the same time, we want to see that our workers are more happier than what they were earlier. That we call this humanization of manufacturing systems. And when we call the humanization of manufacturing systems, we are definitely interested to see that workers are satisfied as well as productivity of the organizations is also increased. So that we call worker satisfaction with increased productivity. Now, appropriate job design. As we are talking about this worker satisfaction with increased productivity and mindless stereotype job moving towards the planning and controlling activities, in that case we need the appropriate job design. There are various theories available for appropriate job design. So first one is that some of these are socio-technical systems. It has been developed in Britain in 1960s. That technical and social system has been combined together, and that we call the socio-technical systems. After all, production system has a heavy bias on technical systems, because the process of conversion is nothing but the technical systems. That is what we call technical know-how. So technical system has certain advantage, disadvantage. Similarly, social system has certain advantages and disadvantages. So how to combine these things, two things, that we call the socio-technical system. Then job enrichment and job enlargement. These theories, they try to give the planning and controlling work to the peoples. Then another thing, tall structure and flat structure. Tall structure, olden days we have the tall structure, hierarchically 4 or 5 layers we have, but today we have the much lesser layer in any organization, good organization, and that we call the flat structures. Unless we demolish the tall structure into a flat structure, in that case there is no possibility of giving planning and controlling task to the workers. That is impossible. And if planning and controlling activities cannot be given to the workers, in that case the possibility of this JIT, TQM is ruled out. One more thing that is very much considered about the product design as well as the workplace design, that we call man-machine interfacing. After all, man is operating the machines, and man will always be required to operating the machines. And this subject, how to design the workplace, how to design the product which will be utilized by the human being, that process of thinking we call ergonomics. Then we have the material resources, physical facilities, plant and equipment, and then materials, inventories and supplies. And today what is happening, the process of doing the business is getting changed. We are depending upon the more outsourcing. So suppliers and inventories, it is getting more importance than what it was earlier. So we need to think that how we build up the collaboration or cooperation with the suppliers, because we are gradually more and more increasingly more dependent upon the suppliers, almost it is a practice in all in automobile industries, as well as it is going to be practice in all electronic entertainment industries. So how to operate it? Then capital resources, stocks, bond and debentures, interest earned on the capital and earned revenues. So these are the part of the manufacturing systems. But here also we all these methodologies that we have developed for management of the machines and materials are equally applicable to the service industries. So before going deeper into these subjects, we need to discuss some things that in which way service sectors is different than the manufacturing. So that's why this slide will give you, from this slide onwards, we will discuss slightly about the differences between these manufacturing and non-manufacturing sectors. First difference is that difficulties in measuring productivity in service organization. The way we can measure the productivity in manufacturing industries, that same way it cannot be measured. There is certain difficulties in that. Suppose the health service productivity, how it can be measured? There are lots of difficulties. It is not that straightforward as it is in the manufacturing industries. And why it is different? Because all service operations, that is an application of knowledge, skilled labor and spoken word. Like say medical services, the doctors and patients, successfulness of the doctor, it depends upon the individual character, individual qualities of the doctor, how much knowledge and skill he has developed in identifying the disease of the patient, giving the correct type of medicines, and how he behaves with the patients while interacting with the patients. Same thing is applicable in case of the restaurant industries, many other service industries like legal service, legal consultancy, management consultancy, many other types of work. That's why that makes it difficult for measuring this productivity in service operations. There are other difficulties also. Difficulties in establishing quality standards in service operations. Quality standard also cannot be specified as in the case of manufacturing industries, because the product in manufacturing industries has the physical dimensions and many other characteristics which is defined at the time of the design stage, and manufacturing job is to conformance to that design. Here in case of the non-service, non-manufacturing industries or service industries like restaurant, hotel, hospital, then health sector, it is difficult to have that kind of quality standards. Product quality is more difficult to establish in service operations. Persons who provide service generally have contact with customers, which is not true in case of manufacturing industries. Maruti as a concern is manufacturing largest number of cars in our country, but they do not have direct contact with the customer. They deliver the car to the customer through different distribution channel, but they do not have the direct contact with that. But at the Apollo Hospital, doctors have the direct contact with the patient for delivering the service. So far we have not implemented the telemedicine. Even in the telemedicine, doctor has to inform by the patients his problems, and on asking the questions by the doctor for further probe, patient need to answer. So this kind of system is not existing or is not required in case of the manufacturing industries. No scope of inventory holding in service operations. In service operations, there is no scope of inventory holding. And inventory holding is very much practiced in case of manufacturing industries. Because in manufacturing industries, we have the three kinds of inventory. One is the raw material inventory, work in process inventory, and finished goods inventory. Then specific characteristics of manufacturing. greater percentage of fixed assets invested in facilities, equipment and inventory. More expenses in material handling, which is not required in case of service industries. Heavily dependent on maintenance and repair work. Manufacturing industries cannot operate without efficient maintenance and repairing work. Partially it is true in some of the non-service sector also, like in hospital, you require the X-ray machines, many other diagnostic machineries are there, and sophisticated diagnostic machineries are coming up. Efficient operation and maintenance is required, but the way it is required in the manufacturing operations, it is not required in that way. That's why manufacturing industries invest heavily on this kind of equipments, material handling equipments, machineries, plant and machineries and inventory, which is not true in case of the service sector. So in all these things, what is the role played by the managers in operations or manufacturing industries? Three basic requirements for successful company. It must provide a product, goods or services that is suited to the company's capability and for which there is a sufficient market. This is the first requirement. Otherwise there is no need to operate any manufacturing industries. It must provide the product with consistent quality at a level that appeals to the intended customers and services their needs. Now it is not that if there is a wide fluctuation of the quality from batch to batch or time to time, then customers will not come for repurchase of your goods. You will get that organization will definitely get the bad reputation in the market, and it cannot operate for a longer period of time. Another qualities is required. It must provide the product at a cost that allows an adequate profit and a reasonable sales price. Skill needed by the operations and manufacturing managers. First one is the technical competence, understanding the technology with which the production system works. And in fact, different production system has the different kinds of technology. Like shoe manufacturing, in the technology required for the shoe manufacturing farm is different than the technology required in an integrated steel plant converting the iron ore into some finished product. Same thing, what is required technology required in the four-wheeler manufacturing farm is not required in case of the refrigerator manufacturing farm. But the operations manager or manufacturing manager must understand the technology with which the production system works. Adequate knowledge of the work they are to manage. Then behavioral competence. Man is a social animal. So social interaction among the workers and subordinates, supervisor, junior executives, that is also very much. Consider the social as well as physical aspects of the work and workers. Interpersonal work, ability to work with others. All these points that I am discussing, it requires for the team building in the industries. And today's manufacturing, in the successfulness of the manufacturing industries, that depends upon the proper team building task. And Japanese manufacturing industries, they have succeeded in this task properly in 1980s decade, and that's why they could able to replace the British goods as well as many of the American goods. And even the Japanese firms, they are purchasing the American manufacturing industries as well as British manufacturing industries. Today we never heard about the British car, but if you look back in 50s, 60s decades, you will find mostly Indian roads were filled up with the British car. Today we never heard about the British car. On the other hand, all British car manufacturing firms was purchased by mostly Japanese and German firms. And this is the crux of that successfulness, that they could able to build a proper team in their manufacturing organization to control all other activities of that firm. Now schematically we see there are another diagram in this where we see that how it is different. You see the operations, we have the two varieties, manufacturing and non-manufacturing or service. In manufacturing, what we see? Tangible output. And criteria where to hold the inventory for better service to the customer. On the basis of that, we can have the three types of industries. First is that make to stock producers. Mostly all consumer durable industries or consumer good industries are make to stock. Like you say Hindustan Lever, they are the largest manufacturer of toilet soap as well as detergent. They never start manufacturing after getting order from the customer. They have certain estimation that how much they can sell in the market, and on that basis of the market they make their production plan, yearly production plan, and they make stock in that. Same thing of the all toothpaste company. They have certain estimation. So these kind of industries we call like TV industries, they never wait for the customers' orders. They have certain methods of estimating the, or we can say the forecasting the market demands. On the basis of that, they start manufacturing of TV or refrigerator or automobiles in that way. These firms we call as the make to stock producers. Another varieties of firm, make to order producer, like BHEL. BHEL is the largest manufacturer of equipments for thermal power plant in our country. BHEL always works on the basis of the make to order, and mostly NTPC and all other state electricity board power plant, they take the equipments from the BHEL. So they place the order for the BHEL, and as we know today that if you place an order today, you will get the supply 2.5 years after that, because BHEL order book is filled with the order and they try to execute the order as per the scheduled due date. Same thing, any heavy equipment manufacturing firm, they always, or special equipment manufacturing firm, they always operate on the basis of the order given by the customer. This we call make to order firm. Another categories of firm is their assemble to order. These assemble to order firms is a separate kind of firms. Take the example of electronic entertainment industries, mostly TV, or we can say audio video systems. Any manufacturer is providing at least 30 different varieties of product. Say Philips or LG or Sony, they are providing in the market at least 25 to 30 different models of that, and there cannot be 25 or 30 different assembly line for assembling each product. So how do they do it? Usually we call it is a modular system of design. The product has been designed with the number of modules, and with the permutation and combination of the number of modules. Suppose we have the 4 modules in each TV, and every module has a number of components, and these 4 modules we arrange in a different way as per the requirement of the different countries. Like Sony is operating in India, Sony is also operating in Africa, Sony is also operating in Latin America. But the model that they are selling in India may not have a market in Latin America. They might have the different model. And it is not that they are manufacturing everywhere they have a plant and everything they are manufacturing as a fresh product. Some of the products are common to them. And these kind of things we call, that means in midway we have this final product, sub-assembly, and then components. So components will be assembled into sub-assembly, and then sub-assembly will be assembled into a finished product. So this sub-assembly, number of sub-assembly, they manufacture in a different place. and that's why we call it as assemble to order. Similarly, we have a non-manufacturing or service sector, that is a tangible output and intangible output. Tangible output, again intangible outputs, we have the two categories, that customer is not a participant, another is a customer is a participant. So here we end the first lecture. And here one more thing I want to point it out, that gradually in many of the sectors, this third category of manufacturing, that assemble to order, that is increasing. Like you can imagine, even in our country, Maruti is producing only 7 or 8 types of car. And if you look at this, the design of this car, there are mostly, there is a variation in the outlook of the car. Many of the things are same. Like gearbox, either it will be 4-speed gearbox or 5-speed gearbox. Engine capacity is either 800 or 1000 or slightly above of that. And all models are equal. If you look at the better car manufacturing firm of the world, like GM, Volkswagen, or this kind of, or Toyota, you will find many of the things are common. And that we call this assemble to order. Actually, the whole manufacturing industries or goods manufacturing industries are moving towards assemble to order, because it gives us, or it gives the manufacturing organization to organize their manufacturing throughout the world in a different way. And thus we end it here.